Okay, class, good morning. So for today, let us answer the sample problem given in the notes where you are to solve for the forward and backward bearing of each line. So forward meaning that is from point A to B, that is forward. And then from B to A, is backward. Okay. So for the problem that is from the open compass traverse shown, if the forward bearing given is this one, north 75 degrees 30. By the way, bearing is, or the bearing of the line is the acute horizontal angle between the reference meridian and the line. So for example, you have the reference meridian and the reference parallel. This one is the reference meridian. This one is the reference parallel. Okay? So, in our case, we are given line AB. So, for line AB, this one. So, this is the reference meridian. Okay, so therefore, we have our bearing from A to B. Is drawn from the reference meridian to the line. So, this is north 75 degrees 30 minutes east, or just the angle 75 30. Okay, so we are to solve for the forward and the backward bearing of each line and the forward and backward azimuth of each line. By the way, azimuth is a direction given by the angle that is from north or from south. So you have there the azimuth. It's either from north or from south. Okay, so we all know that in our orientation, this is north, this is south, this is west, and east. So for the azimuth, this is always from north or from south. Okay, so let's answer the problem. So we have the tabulated data for lines AB, BC, and CD. So normally we have the bearing for forward. So bearing, it should always be with the direction. So to solve for that, you have the bearing for line AB. So bearing for line AB that is given is north 75 degrees 30 minutes east. Okay, and then next is the bearing BC. So that is forward. So therefore, we have here the reference parallel. So you cannot do the bearing from the north since that is now an obtuse angle. We are to have it as the acute angle. Acute angle that is from south. Okay. So how much is that? So we can have this is the deflection of the line. since deflection angles, it is the angle between a line and the prolongation of the preceding line. So this is the preceding line. So you just prolong or extend that, and then from that line to line BC, that is the deflection angle. Okay, deflection. So for our computation for the bearing of BC, so we now have, so this one, this total angle, this angle, this one, this is equivalent to a straight line, which is equal to 180 degrees. And for this one, this angle, this is just the same angle as your bearing. Okay, so for this angle, this is equivalent to this one. So therefore, you have this angle equivalent to 75 degrees 30 minutes. So to solve for this angle, this one, you have just 180 minus this deflection angle and minus the forward bearing of AB. Okay, so to solve for that, you have the calculator. Okay, so you have 180 degrees minus 40 degrees 15 minutes minus 75 degrees 30 minutes. So you have 64. By the way, that is 64 degrees 15 minutes. Okay, so we now have our bearing for line BC, that is from south. So this is south, 64 degrees 15 minutes east. This is going to east. Okay, so we have the bearing for line BC. Next, we have the bearing for forward bearing for line CD. Forward bearing for line CD. Okay, so for line CD, to solve for that, we have already the our bearing for line BC. So we can solve now the bearing for, or backward bearing for line BC. So for this one, we have the reference meridian, and then the backward bearing. This is 64 15. Okay, 64 15. degrees 15 minutes. Okay, and then to solve for that, we have to solve for the forward bearing of line CD. We'll have this bearing, forward bearing. So to solve for this, we are given an azimuth. For point D, which is from north. that is the azimuth. So for this one, this is for the reference meridian, that one, that is equivalent to 180 degrees. So therefore, to solve for this, one, that is just 250 degrees 10 minutes minus 180 degrees. Okay, so we have the calculator. 250 degrees 10 minutes minus 180 degrees. So that is equivalent to 70 degrees 10 minutes. Okay, so for this one, for this backward bearing for line CD, that is just equivalent to the forward bearing of your line CD. Okay, so for the forward bearing, that is equivalent to 70 degrees 10 minutes. So therefore, you have there, and that is from north to east. Okay, so you have north 70 degrees 10 minutes east. Next, we have the forward bearing, forward azimuth. Forward azimuth, that is from north. Okay, so for line AB, the azimuth is from north going to the line. So that is just equivalent to the bearing. So therefore, we have the azimuth from north, that is 75 degrees 30 minutes. So we have no direction for the azimuth, since in the problem we are to solve the azimuth from north. So no need to have the direction. Okay, so next we have the line BC. Okay, so for line BC, we have line BC. So to solve for the azimuth from north, that is from north. Okay, this from north to the line. Okay, for this one, this is equivalent to 180 degrees. That is the reference meridian, 180, minus this one, so 64 degrees 15. So you cannot solve directly the problem if you don't have the illustration or the drawings. So that is now 180 degrees minus 64 degrees 15 minutes. Okay, so that is equal to 115 degrees 45 minutes. So therefore, you have now your azimuth from north, that is 115 degrees 45 minutes. Okay, and then for line line CD that is from north, so this one. So by the way, for the azimuth, that is always clockwise direction. So for from north going to this line, so this is just equivalent to the bearing, which is 70 degrees 10 minutes. Okay, so this is 70 degrees 10 minutes. Okay, so next you have the azimuth that is now from south. Okay, so from south, that is always clockwise direction. So you have there from south going to the line. Okay, so that is from south to north, that is 180 degrees, and then going to that line, so you just add the bearing. So therefore, that is 180 degrees, 180 degrees plus, okay, so let's have the drawing, 180. So this one, from south to this one. This is 180 degrees plus 75 degrees 30 minutes. Plus 75 degrees 30 minutes. So that is equivalent to 225 degrees 30 minutes. So 255 degrees 30 minutes. Okay. So next for line BC, the same, that is from south. So this one from south. Okay. So therefore, this is 180 already. This one, 180. So from south going to this one, you can have the formula by 180 degrees plus 115 degrees 45. You can have that, or you can have the whole rotation, that is 360 degrees minus 64:15 minutes. So depending on how you draw or how you solve the problem, as long as the same result. Okay, so can have 360 minus 64 degrees 15 minutes. Okay, so you have 360 degrees minus 64 degrees 15 minutes. Okay, so that is equivalent to 295 degrees 45 minutes. Okay, and then lastly, you have for line CD, that is from south clockwise direction going to the line. So therefore, this is 180. So 180 degrees plus the bearing, which is 70 degrees 10 minutes. So you have 180 degrees plus 70 degrees 10 minutes. Okay, so therefore you have 250 degrees 10 minutes. Okay, so now we have the backward bearing. So for the backward bearing, we start with line CD. Okay, so we'll start with line CD so that we have the direction from right to left. For the forward bearing, we have that as left to right. Okay, so we start with the bearing of line CD, that is backward. So we are given, or we already solved that one, is the back bearing. but that is now from south to west, but the same angle. Okay, so you have now your bearing of line CD, which is from south 70 degrees 10 minutes west. Okay, and then for line BC, so backward, so going from, that is from right to left, so that is from reference meridian. So you have now the bearing for line BC, which is equivalent to 64 degrees 15 minutes, but for the direction that is north going to west. Okay, so therefore you have your answer, that is north 64 degrees 15 minutes west. Okay, so that is just the opposite direction of your forward bearing. Okay, opposite direction. Then you have line AB. So line AB is the, for the bearing, that is from the reference meridian to the line, acute angle, not this one. Okay, that is the acute angle. So therefore, we already solved that. That is 75 degrees 30. But that is from south to west. That is the opposite for your forward bearing. Okay, so you have here south 75 degrees 30 minutes west. Okay, next we have the north azimuth. Azimuth from north, that is backward. So backward from north. So for example, so we still do the same. We'll have to start first from right to left, but maybe you can start also from left to right, as long as all the angles are already solved. Okay, but for me, I will start from right to left, so I will start with line CD. Okay, so for the azimuth for line CD, that is from north, so clockwise direction, so that is from north going to this line. Okay, so therefore that is 180 plus this one, or that is already given, which is 250 degrees 10 minutes. Okay, so this is 250 degrees 10 minutes. Okay, and then by the way, that is from CD, 250 degrees 10 minutes. Next we have line BC, so that is from north. Okay, this is the north, so clockwise direction to line BC, this one. So therefore you have this one is equivalent to 270. That is 3 areas, no, 3 quadrants. So per quadrant, that is 90. So for this one, that is now 3 quadrants, so therefore that is 270 degrees. Okay, so to solve for that, you can have 270 degrees plus, that is 90 minus, or 90 degrees minus 64 degrees 15 minutes. Okay, you can have that, or that is the total 360. Okay, so 360 degrees minus this angle, the bearing, 64 degrees 15 minutes. So it depends on how you solve the problem from the given data. Okay. Okay, so you have this as easy solution. So that is 360 degrees. Okay, 360 degrees minus 64 degrees 15 minutes. So you have 295 degrees 45 minutes. Okay, so you have 295 degrees 45 minutes. And then we have line AB. Okay, for line AB, azimuth from north, so this is the north. So going to line AB. Okay, so that is now 180. It is 180 degrees plus the backward bearing. So you have 180 degrees plus 75 degrees 30 minutes. Okay, so 180 degrees plus 75 degrees 30 minutes. So that is 255 degrees 30 minutes. Okay, so that's for the azimuth from north. Next, we have azimuth from south. So for azimuth from south, I will start also from right to left. So for the azimuth from south, this is now your south going to this line. So that is just equivalent to the bearing angle. Okay, so you have 70 degrees 10 minutes. Okay, and then next you have for line BC. So this is south going to this line. So that is just 180. Okay, this one was 180. So minus this angle 64. Okay, so therefore that is 180 degrees minus 64 degrees 15 minutes. That is 115. So go from south going to this one. That is 180 minus 64 degrees 15 minutes. So that is equivalent to 115 degrees 45 minutes. And then lastly, you have for line AB, azimuth from south. So that is from south going to this line. That is equivalent to the bearing angle. So this is 75 degrees 30 minutes. Okay, so you solve all the required data. So that's the answer for the problem.